Okay. So we are going to discuss one example of how bisection method is used to solve an equation. So the question is this: find a root. Find a root of the equation. Find a root of the equation. What is the equation? Equation is x cubed minus 4x minus 9 equal to 0. Using the bisection method. Using the bisection method in 4 stages. In 4 stages. I'm going to find a root of the equation x cubed minus 4x minus 9 using the bisection method in 4 stages. There you go. So the solution is definitely. So first we'll start with let f of x equal to x cubed minus 4x minus 9. Already here 6 data x data. First we'll insert x equal to 0. When we put x equal to 0, this is 0, this is 0, and this is minus 9. So f of 0 is minus 9. Now let us put x equal to 1. X equal to 1. So then f of 0 equal to minus 9. F of 1 equal to, now you put this 1. So this is 1 minus 4. 1 minus 4 is what? Minus 3. Minus 3 minus 9. This is minus 12. Now let us put x equal to 2. X equal to 2. And what is this? This is 2 cubed, 8. So this is 8. And this is also 8. So 8 minus 9. This is minus 9. Now then let us put f of 3. Let us find f of 3. This is 3 cubed. What is 3 cubed? 3 cubed is 27. Minus 3 times 4. 3 times 4 is 12. Minus 9. 9 got 12. This is 21. 27 minus 21. This is 6. Now we see that the value of the function at x equal to 2 is negative. The value of the function at x equal to 3 is positive. From this, we can see that the value of f at x equal to 2 is negative, and the value of f at x equal to 3 is positive. From this, we can say that therefore the value of f at 2 multiplied by the value of f at 3, this is less than 0. Hence, the root lies between x equal to 2 and x equal to 3. So the root lies between x equal to 2 and x equal to 3. So now we have found an interval. And what is the interval? The interval is from x equal to 2 to x equal to 3. At x equal to 2, the function is negative. At x equal to 3, the function is positive. Therefore, the root lies between these 2 points. Now, according to the bisection rule, what is the next step? Next step is to find the middle point of this interval. And that middle point of the interval is the first approximation to the root. Therefore, first approximation. Therefore, the first approximation to the root. Therefore, the first approximation to the root is this is x1. X1 is equal to 2 plus 3 divided by 2. And this is nothing but 2.5. This is 2.5. Now let us calculate the value of f at 2.5. Now say that the value of f at x1. This is the value of f at 2.5. 2.5. And what is this? This is 2.5 whole cube minus 4 times 2.5 minus 9. Minus 9. Now we have to use a calculator here. So we'll use a calculator and we'll find that this value is minus 3.375. We'll find that this value is minus 3.375 using a calculator. That means the value of the function at 2.5, this is less than 0. This is less than 0. Adu origadi ekoi hojik kari khangre at x equal to 2, the function was less than 0. At x equal to 3, the function was greater than 0. Now at the midpoint of this interval, 2, 3 interval, at the midpoint 2.5, the function is less than 0. The function is negative, that is less than 0. So what is the new interval? New interval new interval amana less than 0 already, amana greater than 0 So at 2.5, the function is less than 0. Then we should find the point where the function is greater than 0. And the point where the function is greater than 0 was 3. 3 natra. So the last point where the function was greater than 0 is 3. So now, hence the root lies between. Hence the root lies between. Hence the root lies between x1, that is 2.5, and 3. Because at 2.5 the function is negative, and at 3 the function is positive. So the new interval is now 2.5 to 3. Now this is my new interval. Therefore second approximation. Therefore the second approximation ROXIMATION. Therefore the second approximation to the root is now this second approximation, we call it x2, and this x2 is equal to, this is 2.5 plus 3. Sigi interval is midpoint 2.5 plus 3 divided by 2, and this we find it to be 2.75. Question kari haiba? You find the solution in 4 stages haiba. So we have to find the fourth approximate solution. Now we have found the second approximation. We have to go up to the fourth approximation. So we have here. So what was the second approximation? The second approximation was 2.75. Here we have just seen that the second approximation to the root is 2.75. Now let us calculate the value of this function at 2.75. So now, now f of x2. F of x2 is f of 2.75, and this is 2.75 whole cube minus 4 into 2.75 minus 9, and we calculate this value with the use of a calculator, and this value turns out to be 0.7969. And this is greater than 0. So, and this is a positive number. So it is a positive number. So when in the second step, the root lies between 2.5 and 3. 2.5 amasung 3 gi barakta root se leirani haigrabni. At 2.5 the function was negative. At x equal to 3 the function was positive. The function was positive. At 2.5 the function was negative. At 3 the function was positive. Now at x2, that is at 2.75, the function is positive. Hence, the root now lies between the positive already negative negative because 2.5 to 3 to 2.5 to the value of the function was negative at 2.5. Therefore, the root lies between 2.5 and 2.75. So hence, the root lies between say the x1 and x2. That is 2.5 and 2.75. Tareco. Sibokti kya tareco. Adone jekonu kaino 2.5 ka 2.3 ka paraktal akoi magi root ama laini havani adagi root to hotpada koi 2.75 phange. 2.75 say the function z, the value of the function at 2.75, it turns out to be positive. Positive natra. Adudi akoi hanagi intermediate value property na kari haiba, the root should lie between the positive and negative values of the function high because aduna at 2.75 since the function is positive adu itardi I side 2.5 the function is negative or gibra but 3 the negative or giba do yangani, and we found that the function was negative at 2.5. So now the root lies between 2.5 and 2.75 because at 2.5 the function is negative and at 2.75 the function is positive. Uneasy mark the root to live tower. So that is the third approximation policy. The third approximation to the root is any now the third approximation to the root see interval midpoint it should lie in the midpoint of the interval 2.5 and 2.75. So the third approximation of the root is x3 equal to say the 2.5 plus 2.75 divided by 2. And this will turn out to be 2.625. This is 2.625. Now let us calculate the value of the function at this point at x3. Now the value of the function at x3, this is equal to 2.625 whole cube minus 4 times 2.625 minus 9. And this value is actually a negative number, minus 1.4121. And this is less than 0. This is less than 0. This is less than 0. Therefore, if you check, so 2.5 and 2.75 interval at the midpoint of this interval, that is at 2.625, the function is negative. Now let us try to remember whether the function was what the value of the function was at 2.5 and 2.75. 2.5 the function is positive or given negative or given at 2.5 the value of the function was negative. Okay. At 2.5 the value of the function was negative. And at 2.75 the value of the function was positive. Now we have found the midpoint of this. So 2.5 to the negative area, 2.75 to the positive area. Now at the midpoint of this interval x3, we found that the value of the function at x3 is negative. Therefore, in a negative area, the negative to positive uneasy. Therefore, f of x2. This is 2.75 is x2, 2.5 is x1. Therefore, So this is my f of x2 higher, therefore f of 2.75 multiplied by f of this 2.625. F of 2.625. 2.625. This is less than 0. At this point, the function is positive. At this point, the function is negative. And multiplying a positive number with a negative number, we get a negative number less than 0. Aduna function is opposite sign less than 0. Hence, the root lies between. Hence, the root lies between. Hence, the root lies between 2.625 and 2.75. So pause again. Zoom recording. So the value of the function at 2.75 and the value of the function at 2.625, they are of opposite signs. Therefore, the root lies between 2.625 and 2.75. So this is the second approximation to the root. This is the third approximation to the root. Now the next approximation, that is the fourth approximation to the root, will lie at the midpoint of these two numbers. Hence, therefore, the fourth approximation. Therefore, the fourth approximation to the root is x4 equal to 2.625 plus 2.75 divided by 2, and this value is 2.6875. What was the question? The question was, find a root of the equation x cubed minus 4x minus 9 using the bisection method in 4 stages. Four stages. Now we have calculated the first approximation. Then we have calculated the second approximation. After that, we have calculated the third approximation. And finally, we have calculated the fourth approximation. So this is the required answer. So hence the root is 2.6875 approximately. Hence the root is 2.6875 approximately. So let me write this as page number 2. This was page number 1. So this is how we use the bisection method to find the root of a given equation. In the question you are asked, to find the root of this equation in 4 stages. 4 stages the follow happening. In some other question, you may not be given the stages, number of stages. Number of stages if the way question find the root harga correct up to 3rd decimal place, correct up to 4th decimal place. Then in that case, you will calculate the roots. So for example, if you are asked to calculate the root of correct up to 3rd decimal place, of the correct root you in the first approximation and in the second approximation and in all the following approximations, you should calculate up to the 4th decimal place. 3rd decimal place for correct you have you should calculate the root up to 4th decimal place. Aduga first approximation, second approximation, third approximation, consecutive approximations, you will compare their values. Compared to whenever. Values look like change to whenever. These values will keep on changing. But the moment the change stops at 3rd decimal place, 3rd decimal place also change to consecutive successive roots into successive roots. If the number up to the 3rd decimal place does not change, fourth decimal place change tawjabadi kaide, third decimal place level number to change tawaktraba. In that case, you can stop and you can say that this is the value of the root correct up to third decimal place. Correct. Okay, then this is how we find the root by using bisection method. After bisection method, let us look at another method. Atop method ama uyang asi adugi method tuna kari kauke haibu adugi method tu yang tinida. Before coming to that method, we should remember two important points. Two important points while applying the bisection method. First point is that while applying the bisection method, we must be careful to check that the given function is continuous. The function is continuous or never. The given function should be continuous. While applying the bisection method, we should check that the given function is continuous. Here, the given function is a polynomial function, and every polynomial function is continuous. Therefore, we can apply the bisection method. The function continuous over check because bisection method say theorem the base of now bisection method is based on the theorem that nanagi theorem the intermediate value property. If the value of the function at a is negative and if the value of the function at b is positive, then a zero of the function lies between a and b. And in the interval a to b, we can find at least 1 0 of the function. Intermediate value property do we apply intermediate value property only for a continuous function. We should be careful to check that this is a continuous function. Only then you can apply the bisection method. Next, the second part, it may happen that a function has more than one root in an interval. A function can have more than one root. So the bisection methods helps us in determining only one root. Bisection method is the only one root. We can determine the other root by properly choosing the initial interval. We can determine the other root by properly choosing the initial interval. So, example, suppose we can look at one example. One example is simple example. X square minus 3x plus 2 equal to 0. The answer is very simple. See quadratic equation, the answer is very simple. So we can easily see that the two roots of this equation are 2 and 1. The two roots of this equation are 2 and 1. 2 and 1. Interval 2 ga 1 ga animak se interval if my interval contains both 2 and 1 inside it. So when I solve this by using a bisection method, and if I choose an initial interval which contains both 2 and 1 inside it, bisection method will determine only one of those two values. 2 nataga 1 dagi manungda value ama kitang thirakane value animal bisection method it will find out only one value. Value animal we should be careful while choosing the interval. Okay. Next, we can now move to the second method. The second method is called the method of false position or Regula falsi method. So the second method, let me write down the second method. This second method is called right here, Regula, R-E-G-U-L-A, Regula falsi, F-A-L-S-I falsi method. This method is called Regula falsi method. This is also known as the method of false position, the also known as no, also known as the method of false position. False position. This is also known as the method of false position. This comes from the Latin word regula falsi. Regula falsi have a Latin word. Meaning the rule of falsehood. Regula falsi. This Latin word means the rule of falsehood. Then does it mean that the rule is a false statement? The rule of falsehood sigi rule is false statement. I'm the base rule. No. It conveys the message that the root that we get according to this method, the root that we get according to this method, that root is only an approximate root and not necessarily an exact root. Sigi method sidagi phangiba root che adu approximate root ni haibadani ko regular false in mean torise. Regular false in mean torise what the value that we get as a root is only an approximate value and not necessarily exact value. Aduga sigi method che this method is somewhat similar to the bisection method. Sisu bisection method karamani ko. This method also involves finding an interval A and B have an interval such that f at A and f at B, these two have different signs. So when I multiply them, it should be less than 0. So this method also requires finding an interval A to B where the value of the function at A and at B are of different signs. Aduga bisection method tagi magi advantage na kari no haiba matamda bisection method ki drawback kari no haiba matamda bisection method does not make use of the value of the function. The bisection method only uses the sign of f, a, and b. Bisection method tadi we can consider only the signs of the function at these points. In the last example that we have also seen, bisection method only considers the sign. It does not take into account the value of the function. Sign value aduna maduma gi drawback ni others madugi do the example so for example I have this this is A, this is B. At A the value of the function may be very large, and at B the value of the function may be very small. This is FB, this point is B. This point is A, this is f of A. So if at the point A, if the value of the function is quite large, and at the point B, if the value of the function is quite small in magnitude, in such a case, what normally happens is that normally the root lies closer to the point B as compared to the point A. Function की value B है वो point से function की value पिकता है root से necessarily it lies closer to B ने वो अदुबो अखोइना bisection method तरी कदोगनी interval अमा फंगदी what was the first approximation to the root in bisection method. The first approximation to the root is taken to be the midpoint of A and B, and the midpoint of A and B is here. The midpoint of A and B is here. Aduna bisection method tadi kun ngasai A ga B ga mayai se laure function gi value ji khanadra na kadore ai ngasai gi step se sangdore accuracy ji first approximation the accuracy do dum wale ba aduga ai ngasai gi regular falsi method tadi it takes into account the value of the function. Adu egati regular falsi method se combine to have the so geometrically let me draw another diagram. See diagram. This looks like a straight line So let me draw another diagram. Function value is mind to way. So see it again like this. So this is B, this is B, this is A, this is f of x, and this is x. This example. So this point, magi coordinates, A and FA are the coordinates of this point. And what are the coordinates of this point? This point is B and FB. The coordinates of this point are B and FB. Okay. Regular falsi method na hari sinang kari hari no hari gadi. Regular falsi method na hari je. Sigi A ga B ga gi midpoint logo gi mahuta. Instead of taking the midpoint of A and B, what do? We join A and B. We join A and B by a straight line. A and B is enough. We join it by a straight line. Straight line. I'm going to join towards so let us join A and B by a straight line. By a straight line. This line intersects the x-axis at the point C. This line intersects the x-axis at the point C. And this C is the first approximation to the root. There you go. This C is the first approximation to the root. Similar to the bisection method, what is the first step? The first step is to find an interval. Is to find an interval AB such that f of A multiplied by f of B is negative. That is, the function has opposite signs at A and B. Opposite signs later. Next step, instead of taking the midpoint of A and B, we join the point AFA with the point BFB. By the point and easy and it's something around by a straight line. These 2 points are joined by a straight line. The straight line meets the x-axis at the point C. So this point C is the first approximation to our root. Next step, next step, if we find out the value of the function at C. We find out the value of the function at C. So this is the value of the function at C. So at this point, the function is negative. Positive point to so what will we do? We will again join this with C. Now this straight line will cut the x-axis at the point D. At the point D. So this D is the second approximation to the root. And what is the real root? The real root is here, which is represented by xi. The real root is here. In successive approximations, the root moves closer and closer to xi, to the actual root. Sigi idea sini aduna siju masagi bisection method to gudi manai adu khenari with karino habada. Instead of taking the midpoints of the interval, we simply join the 2 points AFA and BFB, and then by a straight line, and this straight line cuts the x-axis at the point C. This is the first approximation. And then next we calculate the value of the function at C. Negative so this point will be CFC. And since the value of the function is negative at this point, what do we do? AFA function positive point aduga AFA ziga CFC ziga straight line join torani. Now the function is now this straight line cuts the x-axis at the point D, and now D is the second approximation. Next step, D is the function value then points will join this point DFD with AFA by a straight line, and in this method we will move closer and closer towards the real root xi. This is how we use the regular falsi method, or the method of false position. Okay. apply to so let us see how we apply this. Mathematical form it was. In the first step, first approximation की value do bisection method to be. In bisection method, the first approximation C would be given by A plus B by 2. A plus B by 2. Now, in the regular falsi method, C की value से कितना नतीजनी? C की value से how will we find the value of C? We will find the value of C by considering the equation of a straight line joining 2 points. In mathematical form, how will we find the value of C? We will consider the line joining the 2 points AFA and BFB. So let us calculate the value of C. Do this one again. The formula for the line joining the 2 points when AFA and BFB. AFA and BFB is given by y minus FA is equal to line number singani FB minus FA divided by B minus A into X minus A. Here, what are X and Y? X and Y, X and Y are the coordinates of any point. X and Y are the coordinates of any point on this line. Straight line, any point ki coordinates X and Y never. So this is the equation of a straight line passing through 2 points AFA and BFB. Since the straight line intersects the x-axis at C equals at the point C, since the straight line intersects the x-axis at the point C, 0. X-axis x coordinate y coordinate 0 C, 0. The point C0 lies on the straight line. Lies on the straight line. Sigi lines na x-axis C the point C0 lies on the straight line. C is in x option by 0 is in y option by now we can substitute x equal to C and y equal to 0. Because here x and y are the coordinates of any point on the line, and the point C0 lies on the line, so we can substitute y equal to 0 and C equal to x. Putting, so let me write it on the next page. Next sheet again, and let me write it here. So this is it. So like that, so let us call this equation number 1. Equation number 1 for God. Aduna Saida putting x equal to C and y equal to 0 in equation 1 and y equal to 0 in equation 1 we get. And what was equation number 1? Equation number 1 was this. So this was equation number 1. So if you put y equal to 0, then we get minus FA. So we get minus FA equal to FB minus FA divided by B minus A. Times C minus A. Instead of X, we are writing C. So this is what we get. And we can simplify this. We can simplify this and solve for C. You can bring it towards the left hand side, and you can leave only C minus A on the other side. So from this we can solve for C, and we'll find that C is equal to A times F at B minus B times F at A divided by F of B minus F of A. This is question number 2. So when I simplify this equation, I get equation number 2. Equation number 2 is CC equation is solved. This is y equal to 0. So this expression for C, this expression for C gives an approximate value of a root of f of x. This expression for C gives an approximate value of roots of f of x. Next step, what we do, we examine the sign of f of C. F of C sign and decide in which interval the root lies. F of C sign sign root 2 A dagina C book manunga libra, that C dagi B book manunga libra. So in this particular example, if we see after that we find the value of the function at C, and the value of the function at C turn out to be negative. So in such a case, we find that the root should lie between A and C. A and C ki manung dalay never. Negative whatever, because the value of the function at A is positive and the value of the function at C is negative. Therefore, the root should lie between A and C. The value of the function at C is in a positive, the root will lie between C and B. So, this concept is bisection method concept. Interval theory bisection method ki interval theory. The only difference is in how we calculate the approximate root C. C ki value kamai na hot ki have do. Aduna C ki value yangani adudagidi C ga A ga gi marakta root chala regadi I amuk straight line amma samani like this. C ga A ga gi marakta root chala reganina. Now I join AFA and CFC by a straight line. This line will cut the x-axis at the point D. D value, this value of D will also be given by this formula with B replaced by C. C formula is the B the C replaced D formula, and then D lagi AFA ga DFD ga straight line join and that line will cut the x-axis at another point called E. E ki value to C formula by replacing B by E, and so on. We can calculate the sequence of more and more accurate roots. When will the process stop? We stop the process when either of two conditions are satisfied. when either of two conditions are satisfied. But what is the first condition? The first condition is that the interval containing the zero of the function is of sufficiently small length. Interval when the interval containing the zero of the function is of sufficiently small length, then we can stop the process. Or second condition, the difference between two successive approximations is negligible. The difference between two successive approximations, the difference between two successive values of the approximate root is some pixel accuracy we can stop this process. And go. In equation G, let me write it down in the iteration format. In the iteration format, the method is usually written as C की महत्व x2 नहीं रहने बा, A की महत्व ना x0, B की महत्व ना x1, C की महत्व ना x2. It's written as x2 equal to x0 f of x1 minus x1 f of x0 divided by f of x1 minus f of x0. So the iteration format. So what is the algorithm? Regula falsi method apply to algorithm. The algorithm is that first we find two numbers x0 and x1 such that the values of the function at x0 and x1 are of opposite signs. Next step, we calculate x2, the first approximation to the root, by using this formula. So that is the second step. And then what is the third step? The third step is that if the value of the function at x2 turns out to be 0, then x2 is the required root, but that hardly happens because is not exact root once in a blue moon. So that hardly happens. If the value of function at this point is not 0, then we find we find the value of this function, the sign of function at x2 is the function to be signed to tyranny, and then we'll see at which point, at either at x0 or x1, the function has an opposite sign. X2, say for example, if at x2, if the function has a positive sign, then we'll see whether the function has a positive sign at x0 or negative sign at x0 or x1. A negative sign labor function to negative sign labor point out. We'll find that out, and then the new interval will consist of that new of that either x0 or x1 and x2. So for example, if f of x0 and f of x2 are of opposite signs, then the next approximation lies in x0 and x2. Otherwise, the next approximation lies in x2 and x1. And then we repeat this process, till the magnitude of the difference between two successive iterated values of the root is less than the accuracy that we want. So let us consider one example. Example I'm going to discuss. So let me take a blank sheet. So let us consider one example. So the example. So let me take this here. Example, find a real root. Find a real root of the equation x cube minus 2x minus 5 equal to 0 by the method of false position. By the method of false position. By the method of false position, 2, 3 decimal places. Correct up to 3 decimal places have any call. 3 decimal places of the chumba. Real root to follow. The root that we obtain are only approximate values, and we want that value which is correct up to 3 decimal places. So let us consider a solution. Let bisection method let f of x equal to x cube minus twice x minus 5 equal to 0. Let the function be given by this expression. So what is f of 0? You put x equal to 0, what do you get? This is minus 5. F of 1 half of, what do you get? This is 1 minus 2 minus 5. This is minus 7 plus 1 minus 6. F of 2. What is f of 2? F of 2. This is 8. 8 minus 4. 8 minus 4 is 4. 4 minus 5 is minus 1. F of 3. And this is 3 cube 27. 27 minus 6, 21. 21 minus 5, 16. Thus, we see that at 2, the function is negative, and at x equal to 3, the function is positive. So the root lies between, hence the root lies between 2 and 3. Between 2 and 3. Already we want to use this iteration formula. So we set x0 equal to 2 and x1 equal to 3. So already take x0 equal to 2, x1 equal to 3. By the method of false position. By the method of false position, we get, not by regular falsi method, we get formula. We get x2 equal to x naught f of x1 minus x1 f of x naught divided by f of x1 minus f of x naught. So let us calculate this value. We get x2 equal to x0 f of x1 minus x1 f of x0 divided by f of x1 minus f of x0. And what is x0? X0 is 2. So this is 2 times f of 3. F of x1 is 3 minus, this is x1. So this is 3 times f of 2. And this is f of, what is x1? X1 is 3 minus f of 2. And we have seen that f of 2 is minus 1, f of 3 is 16. So we substitute the values of f of 3 and f of 2. So this is 2 times, what is f of 3? 2 into 16 minus 3 into minus 1 divided by 16 minus 1. There we go. So this is 16 to 32, 32 plus 3, 35. This is 35 by 17. And this value is approximately 2.0588. If you want to find your result correct up to third decimal place, then you should write your answer up to fourth decimal place. Fourth decimal place for we want to find the value which is correct up to third decimal place, then we should write the answer up to fourth decimal place. So this is f of x2. So this is the first approximation to the root. Now let us calculate the value of the function at this. Now f of x2. This is what is f? F is this x cubed minus twice x minus 5. So this is 2.0588 whole cube minus 2 times 2.0588 minus 5. And this value turns out to be a negative number, minus 0.3908. This turns out to be minus 0.3908, which is less than 0. Which is less than 0. So at x2, the function is less than 0. Greater than 0 or 0.2. So at 2, it is less than 0. At 3, this is greater than 0. So the point where the function was greater than 0 is 3. Therefore, f of at x2, and what is x2? F of 2.0588 multiplied by the value of the function at 3 is less than 0. These are opposite signs. Opposite signs are less than 0. So this is page number 4. Okay, then let me write it on another page. Okay, this is not page number 4. This is page number 5. 시작해. 주방에가 Siga, at these 2 points, the functions are of opposite sign. Therefore, the root lies between this point and this point. Hence, the root. Hence, the root lies between. Hence, the root lies between 2.0588 and 3. The root lies between these two. Now 2.0588 and 3 root next step next step take x0 equal to 2.0588 and x1 equal to 3. Slower because we want to apply this formula again. Aduna x0 ga x1 x0 is not 2.0588 lower, x1 is not 3 lower. X0 to 3 lower, x1 is 3 lower. I can interchange these two values. X0 is 3 lower, we can take x0 as 3 and this value as x1. Therefore, f of x0. So the value of the function at this point, we just obtained that value, and what was the value? The value was minus 0.3908. So this is minus 0.3908 f of x1. F of x1 is f of 3. F of 3 is 16. This is 16. So this is 16. Iteration formula formula. Let us call it equation number 1. So from equation number 1, So from equation number one, what do we get? We get x x3 x3 equal to you can see x naught f of x1 minus x1 f of x naught divided by f of x1 minus f of x0. Formula. Now let us substitute the values of x0 and x1. So this is equal to, what is x0? X0 is this 2.0588 into f of x1. And what is f of x1? F of x1 is 16 minus x1. X1 is 3. And what is f of x0? F of x0 is this minus 0.3908. I got divided by f of x1 minus f of x0. F of what is f of x1? 16 minus plus 0.3908. I got. And when we calculate this using a calculator, this value will turn out to be 2.0813. 2.0813. I got. Then again, at x3, we will calculate the value of the function at x3. Positive or negative or positive or x0 x3 x3 the function negative or the root lies between x1 and x3. Formula root now repeating this process, the successive approximations are given by x4 equal to 2.0862, then x5 equal to 2.0915, x6 equal to 2.0934, x7 equal to 2.0941, x8 equal to 2.0943, and so on, etc. Question find a real root of the given equation by the method of force position correct up to 3 decimal places. 3 decimal places of the value is so today here x4 up to 3 decimal place, it is 2.086. x5 it is 2.091. So 2.086 ka 2.091 ka manade. So from x4 to x5 the value changes by a lot. Then from x5 to x6, x5 2.091 ni 2.0915 and x6 is 2.0934. So 0 bhakti manare, 9 bhakti manare, but this is 1, this is 3. Manadre ka. First decimal place bhakti manare, second decimal place bhakti manare, the difference is at the third decimal place. Next you compare x6 and x7. So 2.0941. So first decimal place manare 00 manare, second decimal place 99 manare, third decimal place 4 lere 3 lere manadre. Then you have to find x8. X8 you can see at x8 this is 2.0943. So first decimal place manare, second decimal place 99 manare, third decimal place 44 manare. Okay, third decimal place manner we can stop here. Therefore, the approximate root is 2.094. 2.094, correct, up to 3 decimal places. Ado sigis yango sigis da equina x3 faudi dum madam yam sano kole ado x4 x5 x6 x7 x8 x9 ju matang sangna dum kolaktra sorry simyam ji samjale ko simyam sum ko de ga di ai page yam sanghani adana I have skipped this, but yumda sigi problem ji solve to matamda sigi x4 si swaina sang hola phangadoini x5 si ju sigi iteration formula sisna phangadoini x6 si ju you will find this value only after you calculate this formula aduna aina sida samjilagi ibani ko ado noi ke gero asengodi si sang por ko dog ne ko ado exam gum bor gadi say yam sang na sum what very kalagadi ko x3 box sum no holamo adagi x4 x5 x6 di you can calculate it on a rough paper to calculate toraga. Now repeating this process, the successive approximations are given by and that's why naturally sang sum ile gadi ko ekoi matam jam sangani lamjam kalani aduna ekoi samjan ba yaba jaga khara thiraga we can consider skipping some steps and then writing this values only. Because I think so for today I can stop the recording.